Hey, hello folks. This is the video tutorial for lab number 52, homework number 3. There are two problems here, and I I would like to do problem number 2 first, and then we move on to problem number 1 later on. The problem that we have here is to be done with shell elements. Not solid elements, shell elements. So you're supposed to use as many planes of symmetry as possible and the most appropriate element. Obviously, the most appropriate element is shell elements. And symmetry, look at the problem that you got. The bottom of this box is all clamped, and there is a force applied in the 45-degree direction. This is a square, and it is pushing this thing along the diagonal here by 0.001 inches. Now, obviously, based on the geometry and the restraint and the load, nature of the load and direction of it, that we need to split this thing into two pieces. Okay, so the top piece and the bottom piece, the one farthest away from us and the one closest to us, can be modeled individually. So let's go ahead and do this. Let's see now. We go here and create a part file. Immediately we're going to save this. So I'm going to go File Save Management, Save As, Desktop. I will make a new folder. I'll call it Homework 3, Lab 52. Okay, so we're going to put it in here, and I'm going to call this thing to be my student ID number 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Bernoulli dash problem 2. This is the one to be turned in. Problem 2. Okay. Say okay. And let's make that box. So on that horizontal plane, by the way, notice that I am in generative shape design. This is where join is. Some people ask me, well, how do I find join? Well, if you're in part design, there is no join. Okay, you have to be in generative shape design. And if you don't know how to get there, you go to Start, Shape, Generative Shape Design. Okay, so on that plane, I'm going to draw a square, 10 by 10, 10 inch by 10 inch. So this is going to be 10, and the other one also 10. Okay, exit. Now I'm going to extrude this thing downward. So here, extrude in the other direction. I think it is 2 inches if I'm not mistaken. Yeah, 2 inches down. Okay, and then I need a cap on the top. So the cap on the top, I can use fill, and then use that sketch that you drew, you know, the square that you drew, and there is the top. Okay, notice that there's the bottom of the box, and there we are. Okay, so then I'm going to join this. Okay, join the top, which is a fill, and the side, which is extrude, and say okay. Now I want to cut this thing at the 45-degree angle here. I don't have a plane here, so let me make a plane first. So here's a plane, and the method of making the plane through 3 points. There it is, 3 points. So I'm going to use this point. I'm going to use that point in the corner and one corner on this side. So it makes a plane going through these 3 points. Obviously, this is at 45-degree angle. You can see that. And then I'm going to use the split. Where's the split? Here's the split right there. Split, read this thing carefully. Element to cut is that join, and the cutting element is that plane at 45 degrees. And I keep the other side. Okay, anything that I don't like, I can hide. This sketch I can hide. And this plane I can hide, etc. And these planes I'll leave it the way it is. Now, we are going to add material to this. Add material, metal, and let's make it out of steel. I think that's what it was. Steel, and okay. All right. Now, notice that later on, I want to say that this edge and that edge and that edge, they are planes of symmetry, in the plane of symmetry. But that plane of symmetry is neither lined up with x direction and y, xy or xz or yz. You can see that's 45 degrees. So I'm going to create a local coordinate system, an axis system, right there. See that in the tool, right there, down below, tool, axis system. And I'm going to put it right at the origin. See that you have to select the origin, otherwise it puts it at the global origin right there. I want to put it here because I want to see it. And then I'm going to say, okay, my x, I want it to be lined up, for example, with this line. So notice that here, x-axis, I can select this line, and it automatically it rotates it so that x is now along that line. Okay, good. So in this coordinate system, in this axis system, xy is a plane of symmetry, and I can use that later on. Okay, so this is all done. So we're going to go to analysis and simulation, generative structure analysis, or analysis and simulation, generative structure analysis, whichever you want to. I've customized my screen so that I get there quickly, and change the rendering so that I can see it better. Oops, not this. No. Isometric rendering, change the rendering to the third one so that the colors become like that. All right, what do we know? The bottom of these two are well, actually, let's measure it first. Here is the shell elements right there. See that? Shell, octave triangle measure. I call it shell. You select that. This is the number. It's okay. I'll keep it like that. It's too big, but that's okay. We just want to show you the process. Now, the 2D mesh right there. See this? Not 2D mesh, 2D property. You select that. The entire joint is taken. And last time I did this thing, I put the thickness of 0.5, which I believe is actually the thickness of this box. So let's see now. Yeah, thickness of 0.5 inches. Okay, we say okay. Now, this edge and that edge are clamped. So clamp this bottom edge and that edge. These are clamped. Okay. Now these other three edges, these edges lie in the XY plane, but not the global XY plane. XY plane of the local system or axis system that I created. So let's do the user define. Let's uncheck everything. And I'm going to call this thing symmetry. Symmetry. Okay. So what are the edges? There is this edge and that edge and this edge, but not in the global system, not in the global system, in the user system. And the user system, you have to go and select the coordinate system, which is right there, the one that I just created, axis system 1. Okay. Now, in that plane, in that system, these edges that I picked are in the XY, so they don't move in the direction Z. Right there, perpendicular to it. And rotations are exactly the opposite, just like what we did before. Okay. So they don't move in X. Translation, rotations are exactly the opposite. And we say okay. All right. Now, on that face, I have pressure, 50 psi on that pressure. Right there, you see this? Except that the direction is minus, so that it's pushing down on it. Okay. And I made some comments about why is this thing at the bottom, not at the top. It really doesn't matter as long as it points in the right direction. It has to do with the direction of the joint. Remember I joined this thing? Okay, remember I joined this thing? Okay? Yeah? Say okay. Now, if you want me to convince you, let me go back to my joint, flip the direction, and show you what happened. Join. As soon as you join something, you join a surface, if you double click on it, watch, there's nothing here, but when I double click on it, an arrow pops up. There, you see this? You see that? Okay, so if I flip this and now go back to my analysis, okay, and look at my pressure. Let me double click. There, see this? Double click on it because I don't want it to be negative. I want it positive. I didn't have to do that. I just wanted to show you that whether this ends up on the top or the bottom has to do with the direction of this joint, okay? As long as you get the correct sign so that it pushes it down, that's all that matters. Okay, good. Now, before we run the problem, let me go ahead and save this thing. File, save management, analysis, save as. Student, where is that folder? Let's see now. Homework 3, Lab 52. Homework 3, Lab 52. Let's go to desktop. Homework 3, Lab 52 is right here. And I'm going to give it my name. 1, 2, 3, 4, 5, 6, 7, 8, 9. My last name is Bernoulli. I wish. Bernoulli. Yeah. And this is problem 2. Problem 2. Okay, good. Say okay. And we say okay. This is all done. So we're going to run. Oh, yeah, full. Oh, wait a minute now. There was no pressure here. I'm sorry. I completely misread this problem. I'm sorry. The problem doesn't say pressure. It says you push in that direction. Oh, my God. Okay, so let's go ahead and fix this thing. Where's the pressure here? Low pressure. Completely wrong. There was no pressure. Okay, here's the situation. I want to push this thing in this direction. Okay, so first of all, there's some stuff here that is bothering me. So let me go ahead and hide them. Why is this thing? Why does this have a question mark hanging there? Three edges, user. I selected that, right? Access system. That's fine. Okay, you know what? I don't like the fact that this has a exclamation mark here. So let me delete this and do it again. No, it happens. So select that. User system. User. Oh, the supports are 1. Okay, let's see now. There's this, and there is that, and there is this guy. The access system is the one that I created right there. Selected access system is not valid. Check its definition. The access system must be right-handed and its component must have non-zero length. Okay, so let me see for a second. What did I do here? Let me double click on this. I double clicked on it, access system. Left right-handed, so this is okay. This looks good to me. Okay. I don't see a problem there. Let's go to the analysis. Back to the analysis. Let's check. This is fine. So user defined restraint. User support is these three edges. These three edges. Okay. The access system is this. Cancel. Something is wrong here. Let me double click on this. Let me double click on this. I'm going to uncheck that. Something origin is at that vertex, no problem. The access system, I put it on the edge. X, O, O. Okay. You see this? X along there, Y down. So using the right-hand rule, Z should be going that way. So let me flip the direction of Z. Now it's the right-hand rule. X cross Y should be Z. I'm sorry, I got distracted here. So look, this has to be a right-handed coordinate system. So the way I had it, Z was going that way. It was not right-handed coordinate system. So I flipped the direction of Z. Now it's right. X cross Y is actually Z. Okay, very good. Now we're going to be okay. So let's go back to the FEA. All the stuff that gave me a hassle, it didn't work. Now we're going to fix it. So user coordinate system is this, there, okay? And these three edges are here and there and there, okay? Remember that in that coordinate system, these three edges that I picked lie in the XY plane, therefore there is no displacement in Z, and rotations are exactly the opposite. No mistake here. There. You see, there is no exclamation mark there anymore. Very good. So I made two bad mistakes here. I put a pressure here, I deleted, then my coordinate system was not right-handed, and it was telling me, I didn't bother reading those messages. So okay, fine. Now what you want to do is you want to push this thing to help me. I'm going to, by the way, let me change this thing, the name of this thing, to symmetry. It's good. I make mistake, you learn. Fine. So let me hide some of the stuff. I'm going to hide this. Very good. Now, I want to push this thing in that direction. So first, I have to make it 0 in that direction. Now, one thing you want to make sure, let me uncheck all of these. So I call this thing pushing. Push. Push. Okay, but make sure you don't pick this point, because this is the origin of the coordinate system. You can run it, but then at the end, it's going to come back and give you an error message. Let me hide this. Hide this. There. That is a vertex, okay? And in the direction, in the user coordinate system, the one that I hid, which is in hiding right there, I can select that. Or you can do it from the tree. Okay, access system 1. Now I want to, let me show you what happened. Let me bring this thing. X is along that edge. So I want to, in that coordinate system, I want to push in the direction X. You can see that? Good, good. And then I can change it. Enforce displacement of this guy by the amount 0.001. Remember, X was going this way, so that minus should come out. Here, look. X is going this way, so that minus should come out. We say OK. And this is it. Save everything. Let me save first. It's going to run. Yeah. Okay, so look at the deformation. You know, that doesn't surprise me, because we are applying concentrated force to a location, to a point. Concentrated force, just pushing on the tip of a needle. It's going to look like that. So if you want to look at deformation, this is all garbage. Okay, so but what we're gonna do is we're gonna stay away from that. So first of all, von Mises stress is right here. Let's change the rendering right there. Now we want to stay away. If you want to see the real stress, let's stay away from this, because this is a gigantic stress right underneath the needle point, right? So what we're going to do is to see the stress distribution here, which is right now overwhelmed by that guy. Let me deactivate this, make a box or make a sphere which is away from that box group or sphere group. Let me do a sphere group. There we are. Let me resize it. First of all, move it away from that end and resize it if needed. Okay, that's good. It's going to stay away from that end. So we say okay. And now we're going to say, show me the stress, but not the whole thing. Double click on it. Just show me the sphere group. Where's the sphere group? Right there. And say okay. And we're going to hide that. Now notice that we could not have seen these colors because they were overwhelmed by that gigantic stress, which was at the tip of the needle, and I was pushing on it. Okay, so this is it, and we solved that problem. I made a mistake. I put a pressure that was wrong. Then my coordinate system happened to be left-handed. By inadvertently, I made it left-handed. Then I flipped the arrow, flipped the Z so that it became right-handed. Okay. So and then we did the problem. Okay, let's go and do the first problem. I wasted a lot of time here. That happens. Get rid of this. Get rid of that. Let's look at our first problem. The first problem is this geometry, and let's see now, what do we have here? We have this top circle clamped, and we put a pressure of 50 psi on this face, okay? Now, first of all, you have to do it with shell elements. There's no ifs and buts. And if you look at this problem, you see that there's only one plane of symmetry. You have to cut it like this. Now, if there was pressure here on this side too, 50, then you also cut it like that. But it's not. So let's go ahead and do this. There we are. Part, okay. Okay. On a convenient plane, on that plane, I will sketch something that looks like the part that I had. So it looked like this, I think. Something like that. We're going to clean it up. Okay, let's clean it up. Left control right, left edge, right edge control, right edge control, middle surface, middle axis. Let's make it symmetric. Left point control, right point control, middle axis, symmetric. Very good. Let's put some dimensions here. The dimensions, this is 4 inches. And this one is 4 inches. 4 inches. Oops, 4. And this thing is 4 inches. Okay, exit. And now I'm going to extrude it. Here's extrude right there. See this? Extrude in the surface toolbar in both directions. 1 inch in each direction. So that is what I have here. Now I'm going to draw those circles. And there are different ways of doing it. For example, I can do it first on that top face. I'm going to draw the circle, diameter 1. Diameter 1. Okay. And let me do exit. I'm going to split this. Split is right here, right underneath join. So you select the, oh, did I join? Actually, I really don't have to join here. I don't have to join. That's okay. When in doubt, join it. You don't have to join in this problem, but when in doubt, join. So split, read it carefully. Element to cut is the join. Cutting element is that circle. And I'm going to let the inside go. I do the same thing on these sides. So on that face, I will sketch my good old circle. Is this right? Yep. Okay. So diameter, 1 inch diameter. And the distance from here to there is 2 inches. Distance from that circle to this edge is 2 inches. Let's put it exactly in the middle. Exit. Once again, read it carefully. Split it, the join with that circle. And I repeat it on the other side. Okay, repeat it on the side. So on that face, we'll sketch another circle. Okay, diameter 1. Position of the center to that edge, for example, is 2 to center it exactly in the middle. Exit. Once again, split the join with this fellow, and we say OK. Excellent. Now, some stuff that we may not want, we can hide. So I hit this thing. Okay, so let's apply material to this. Metal, steel on that part. We say OK. Now, because of symmetry, I'm going to cut it with the YZ plane, okay? Because remember, this circle is clamped, and this face is subjected to a pressure. So I'm going to split. Element to cut is that face, that entire joint, and the cutting element is this plane, the middle plane, which was the YZ plane. There we are. This is our symmetry. Okay. Anything that we don't like, we can hide. This I'm going to hide, and this I'm going to hide, and this I'm going to hide. Very good. Okay, so yeah, this is it. Save it, file, save management. I think I didn't do the save here yet. Yeah, save as. In that folder, I have something called problem. This is problem 1. Yeah, I already did problem 2. This is problem 1. Okay, so now we're going to go to generative structure analysis. Do it with a shell mesh right there. That entire face. Let's make it a lot smaller, maybe 0.3. So okay, let's look at the mesh. I'm going to change the rendering here. Right here. You want to see the mesh? Right click mesh visualization. There we are. You see this? Okay, deactivate it. Deactivate. Oops, deactivate, not hide. There's a difference. Deactivate. Okay, good. So what do we know? We know the properties. Okay, 2D properties. Okay, 2D properties. Now, the vertical ones are the vertical one are 0.2 inches thick, the horizontal one 0.1 inch. So what I discussed in class, what I showed you in class is that what we can do is we can do 0.2 the whole thing, 0.2 for the whole thing, that's fine. But then we're going to do a local mesh in the properties, a local property, local 2D property. I'm going to select this face and put a 0.1, and this horizontal one 0.1, and this horizontal one 0.1. Okay, so the vertical ones are the original one that I did 0.2, but these horizontal ones are actually 0.1. Let me hide these things so that they don't distract me. Very good. Let's apply the restraints here. Okay, I just noticed something. This is dimmed, and the reason it is dimmed is I accidentally accidentally deleted the static step here. I'm sorry, I didn't mean it. So what I can do, I can always put it back. Either I can close this thing, go back and come back in it. That's one option. That's one option. If you don't feel comfortable the way I'm doing it, close this, go back to the part, and get back into it so that you don't close it. The other option is insert static case. Notice that the static case that was there ordinarily is not there. That's because I accidentally killed it. Just say okay. There we are. Okay, so now we have restraints and everything popping up. If you don't like that, no problem. You can kill this. You can kill it. Go back there. That's what I did. Go back there, because some of you may not feel comfortable with what I did. Generative structure analysis, static case, say okay. You see the static case? It's not deleted. Last time that I did, it was deleted inadvertently, so let's do it again. Mesh it with this. Let me make it 0.3, just like I did before. Okay, 2D property on the whole thing, 0.2. And then you put the cursor on the property that you created, right to the property, right click, local 2D property. I said select this, see the 0.1 is there. So this horizontal one, and this horizontal one, and this horizontal one, we say okay. And if these are bothering me, I can hide them. Notice that these are not dimmed anymore because the static case is here. Last time somehow it disappeared on me. I inserted it, but since you got you didn't like it, I just went back to the part and back into the analysis. So clamp this edge. Okay. Now these are planes of symmetry. Remember I cut them? So user defined. Notice that this is user from problem 2. Change back to this thing to local. I had to do user here because there it was a slanted face. So here, these edges, 1, 2, 3, 4, 5, 6, 7, 8. These are all lie in the plane of symmetry YZ. YZ, you can see that, YZ. Look at the compass, YZ. So they don't move in the direction X, and rotations are exactly the opposite. This and that, and we say okay. And this face is subject to 50 psi. So here is your 50 psi right there. Is it in the right direction? No, 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 no. Minus. I want to push it down. See that? The arrow is down now. Okay. Good. So let's save this thing. File, save management, analysis, save as. In that folder, this is problem 1, not problem 2, ID number, my last name, etc. You say OK and run it. It'll work. It's finished. So if I make the deformation, this thing will bend down. There we are. We can animate it. The top is clamped. Remember, the top is clamped. If you want to know deflection, there's a deflection. This is gigantic deflection, not realistic, because this whole thing was 4 inches. This is almost 3 inches deflection. Basically, garbage in, garbage out. This is a gigantic pressure that I put up there, or a very thin steel sheet. So it's going to happen. CATIA doesn't know that this is going to yield. So you put garbage here, you get garbage out, but it is right. It is the right garbage. So based on what you told it, it gave you the right garbage. Okay. So let's see now, deflection. This is deflection. Okay, yeah, let's change it, average ISO, and change the rendering to material shading. There we are. Okay. And if you want to look at the von Mises, says he's going to be huge. Yeah, 70,000 psi. Steel has yield stress of around 30,000 psi. So it's all yielded and all these things. He doesn't know. Katia doesn't know. So this is it. I did 2 problems for you. Problem 1 and problem 2. I made 2 big boo-boos and what prevent and fix it. Hopefully you learned something because of my mistakes. Good. So let's stop this.